right, so let's try this one. H2SO4, same process. Who goes in the middle? H doesn't go in the middle. S or O? S is less electronegative. S goes in the middle. S goes in the middle. O's go around. I got some H's. Are the H's going to go on the S or the O? To put it on the S, that would automatically mean that he would have 6 stuff. You don't automatically give somebody more than 4. So I'm going to put the H's on the O's because it's going to be an oxyacid. Okay? Doesn't matter. You can put them on whoever you want, whichever 2 O's. Doesn't matter. Doesn't have to be next to each other. It could be across. All right, now we need to add it up. H has 1 valence, and the S and the O have 6 valence. Okay, so let's see. Let's start with H. So H, each one of those, there's 2 of them, have 1 valence, 1 S with 6, and 4 O's with 6. So that gives me 32. Make single bonds. Everybody gets a bond. Everybody gets a bond. Everybody gets a car. Everybody gets a bond, kind of thing. All right, so now I've got 1, 2, 3, 4, 5, 6 bonds. Each bond is 2 electrons, so that's 12 electrons. So now I'm at 20. Outside in. Hydrogen wants 2, he has 2, he's good. Let's do the oxygens with the hydrogen. He wants 8, he's got 4, so he wants 4 more, so he wants 4, that's 8. I could do that. So I do that. So 20 minus 8 gives me 12. All right, let's do these guys. He wants 8, he only has 2, so he wants 6. He wants 6, that's 12. I have 12, so I do that. Okay, so that gives me 12. I have none left. Next question. Is sulfur happy? He's got 2, 4, 6, 8. He's happy. So this technically is a viable structure. But our question is, can sulfur expand? Can he be happier? Can he be more stable? So let's look, can sulfur expand? Sulfur is here, he's in row 3. Okay, so that means he's able to expand. So let's look. S can expand. So I want to do the math and see will he. So to do the formal charge, I'm going to do the S. I need to do the O's with the H's and the O's without. So O's with the H's, O's alone. We said S's and O's have 6 valence electrons. All right, any non-bonding, just lone electrons on my sulfur? Nope, there's none on the sulfur. How many bonds? 4. And that gives me a +2. Oxygen with the hydrogen, how many on there? 4. How many bonds? 2. So he's a 0, so he's not going to want to do anything. Oxygen by himself, 6. And then he's got how many lone? 1, 2, 3, 4, 6. And then how many bonds? 1. All right, so what does this tell me? So sulfur is a +2. So sulfur says, I would actually like 2 double bonds, if that's possible, please. And the oxygen by himself is a -1. So he can do 1 double bond. But I actually have 2 of these. So what that tells me is that he can make a double bond and he can make a double bond. So that's what we're going to do. So he's going to move and make a double bond. He's going to move and make a double bond. And that would be my final picture. And that would be my final done picture, because now sulfur is at 1, 2, 3, 4, 5, 6. So if I did the math, he would be 6 minus 0 minus 6, which means he's at a 0 formal charge and he's completely happy. And these actually are all zeros. Everybody's at a 0 formal charge. Now, this is where this gets tricky. The next question I could ask you, which would be a different question, like on a test or something, is how many resonance structures does H2SO4 have? Okay? How many resonance structures does H2SO4 have? So let's think about all the possible pictures. So if we go back, we originally had single bonds. All single is a structure. We had one structure with all single bonds. That's a legit structure. But then we moved and made a double bond. We could have one double bond. That makes the sulfur a little bit happier, but he's not still fully. And that could have been where? The double bond could have been here or here. So I had two options. I had two options for where that one double bond could be. Then my final structure, the one we said was the best structure, is when I had two double bonds. And I only had one choice there. So how many total did I have? I had this one, these two were two options, and this. That meant there were 4 total resonance structures. So if I asked you how many resonance structures does H2SO4, your answer would be there's 4. There's 4 resonance structures. Because if it has all single bonds, but my sulfur is happy, he has at least 8, it counts. Okay? It has to be a stable structure for it to count. Now, are all 4 of these equal? No. Okay? This one is the best resonance structure. One single bond, these 2 were equal, and they're not as good as this one, but better than that one, and this one's the worst resonance structure. So I have 4 resonance structures, but they're not all equal in their stability. Okay? As I get more double bonds, I get better in my resonance structures. So let's refresh. If I were to ask you to draw the resonance structure, this would be your answer. If I asked you how many there were, you would say 4. Okay? All right. So now we're going to go back to the ones that we drew before, and we're just going to count resonance structures. So we're going to go back to all the ones we did and say how many resonance structures do I have.